So let's start our today's topic with defects in a crystalline solids. Okay, so since we are now discussing only about the crystalline solids, so what we found in crystalline solid, we found that in crystalline solids the arrangement of the particles like atoms or molecules are in their ordered form. Yes, so but although they are in their ordered form, but there is some defects in them. Okay, that means the arrangement of the particle in crystalline solid is not perfect. There is an imperfection in the arrangement of crystalline solid. Okay, so the first defect is known as what? Point defect, and this defect is very important. Most of the question came from this defect. Okay, and the second one is what? Line defect. So now these point defects are classified into three parts. Okay, the first one is the stoichiometric defects, impurity defects, and the third one is the non-stoichiometric defects. Okay, so the first one is what? Stoichiometric defects. Now these stoichiometric defects are again classified into several parts. Yes, and the first one is what? Vacancy defect. Okay, for now, what is vacancy defect? Now for vacancy defect, let's compare this to structure. This structure is for a perfect crystal. That means what? Where all the atoms or the molecules are in their ordered form. Here the arrangement is in their ordered form. But in this structure you can see that some of the particles, that means atoms or molecules, are missing from their position. Okay, that means these two spaces are what? Vacant. Okay, and this type of defect is known as what? Vacancy defect. Now this type of defects decreases the density of a solid. Okay, and this type of defects are generated or occurs mainly by heating a solid. Okay, so the second part of the stoichiometric defect is what? Interstitial defect. Okay, so what happened in interstitial defect? Now here also let us compare these two structure. This arrangement is for perfect crystal and this one is for interstitial defects. Now what is the difference between these two structure? Okay, in the first structure there are total 1 2 3 4 5 6 7 8 9 10 11 12 atoms are there. Okay, but here there are extra 3 atoms are present at their interstitial site. Okay, and remember one thing, the extra atoms which will added to their arrangement will be smaller in size. Okay, now interstitial site means what? Now interstitial site means a position between the regular position in an arrangement of an atom. Okay, now because of this defect the density of a solid increases because number of atoms what? Increases. Now this type of defects are mainly seen in case of what? Non-ionic solids, but like vacancy defects are seen in terms of ionic solids. Now the next one is what? Frankel defects, and this defect is very important for your exam. Okay, now this Frankel defect is mainly shown by ionic solids. Okay, now what happened in this Frankel defect? Now in Frankel defect, one of the positive charge, that means cation, will dislocates from its original position to the new interstitial site, that means to the new position. Okay, now the original position will remain as what? Vacant. So Frankel defect shows vacancy defect at its original position. Now this positive charge jump or dislocate from this position to the new position. That means at this position Frankel defect shows or creates what? Interstitial defect. That means Frankel defect shows both vacancy defect as well as interstitial defect. Now the Frankel defects is shown by ionic substances that have a huge difference in their size. Okay, that means the size between the cation and anion. Okay, now for Frankel defect the size of the cation should be very small as compared to that of the anion. Okay, now in Frankel defect, or due to the Frankel defect, the density of this solid will remain same. That means the density will not change, because the number of cation and the anion will remain same. Although this positive charge will dislocate from this position, but still this positive charge is there in this structure. Yes, that means number of positive and negative charge will remain same, so density will also remain same. Schottky defect. Okay, now the Schottky defects are mainly occurs due to the missing of equal number of cations and anions. Okay, that means here the number of missing cations and anions are equal. Okay, now if you look at to this structure, then you will see that one of the cation from this position is missing and one of the anion from this position is missing. That means the number of missing cations and anions are equal. Okay, these positions remains as what? Vacant. So the Schottky defect is a part of what? Vacancy defect. Okay, now because of the Schottky defect, the density of this solid will decrease, because at first the number of, or the total number of cations and anions are 18. Now after, or due to the Schottky defects, two of the atom, that means one cation and one anion, is missing from this arrangement. So now the total number of positive and negative charge will be 16. That means decreases. So that's why the density of this solid will decreases. Okay, to show Schottky defects, the size between the cation and anion should be comparable. That means they should have almost equal size to show Schottky defect.